In this lesson, we're going to look at the last two questions in the Unit 2 Specimen 2 Higher Assessment 10 and 11 on the circle. So in this question 10, the diagram shows two identical circles, C1 and C2. C1 has the origin as the centre, that's this one here, and a radius of 3. The circle C2, this one here, passes through the origin, the x-axis passes through the centre of C2, and we have to find the equation of C2. So the equation of C2 is really dependent on the centre point and the radius. Now, it says from here to here is a radius of 3, so I'll just put that in there. And it says up here, radius of 3, which means that the radius of the new circle C2 is also 3. And if the radius of the new circle is also 3, then the centre point is 3, 0. So that's your first step, if you like. Working out, where did I write it? Working out your radius is 3 of the new circle, and the centre point is 3, 0. 3 along and 0 up. From that information, just go to your formula sheet and use your circle formula, which is x minus 3 squared plus y minus 0 squared equals the radius squared, 0, 3 squared. So leave that as it is, and I would really just take the 0 away and remember to square out the 3 to leave you with this. Okay, so one mark here and one hashtag mark for getting this information. Right, last question. Determine if the line y equals x plus 4 is a tangent to the circle x plus 4 all squared plus y minus 1 all squared equals 1. So if we have to prove that the line is a tangent to the circle, we're going to prove that it touches it once and once only. So it's really an intersection question. Where does the line intersect the circle? And to do that, you let y equal y, or sub in this into the y part of the circle equation. So substitute y equals x plus 4 into the circle equation. So what that means is, in place of the y, we put x plus 4. So we're going to rewrite all this with x plus 4 in here, inside the bracket, next to the takeaway 1. And that's going to look like this. So you've got x plus 4 and takeaway 1. Okay, so let's simplify this down. That's going to be x plus 3 squared. Now what I'm trying to do here to prove tangency is either to prove there's only one point of contact through factorising, or we can use the discriminant. If b squared minus 4ac is equal to 0, that proves there's only one point of contact. Now I'm going to use factorising here, but you would get full marks for the discriminant as well. So to get the trinomial to factorise, I need to multiply out these brackets. So let's do the first one. So x plus 4 squared. Try and resist the urge to say x squared plus 4 squared. And remember, it's double brackets, really x plus 4 times x plus 4. That comes out to be x squared plus 8x plus 16. The x plus 3 squared is going to be x squared plus 6x, 2 lots of 3x, plus a 9. And that equals 1. Now remember, get everything over to one side. Oh well, what I've done here is actually I have simplified this side before taking the 1 over, but you can take the 1 over there. But simplify this down, you're going to get 2x squareds, a 14x, and 16 plus 9 is 25. Okay, then take the 1 over, make sure you let it equal 0. Now the easiest way to factorise something like this is to always look for a common factor first. Now I can see that 2 comes out of all that, so you can divide 2x squared by 2, the 14 divides by 2, and so does the 24. So a common factor of 2 out, and then I'm going to put the trinomial into double brackets if I can. Okay, so 2 bracket, you're going to have x at the start, and then you're going to have an x at the start of the next bracket, and then we're going to use you could either use 6 and 2's, that's not going to give me 7, 3's and 4's to make the 12, and that'll also give me the 7, so there's my answer, x plus 3 and x plus 4. And remember, at this point you could use b squared minus 4ac, a being 1, b being 7 and c being 12. Okay, so we can see here that we've got 2 points of contact, one at x minus 3 and one at x is equal to minus 4. So this proves that the line is not a tangent. So the question is, determine if the line is a tangent to the circle. Well, no, it's not. So make a statement, 2 points of contact, so the line is not a tangent for your final hash mark.